Alright. We've got two things we're going to be dealing with today. One's empirical formula and one's molecular formula. We've already talked about how to make the ionic, remember we had the ionic symbols and then we matched them based off of their oxidation numbers. Okay, so with empirical formulas, with covalent bonds, we have what are called empirical formulas and we have molecular formulas. So empirical is simply a ratio, the ratio of the elements in the compound. What happens is they'll take this, they'll to a lab, a thing, and they'll run tests on it, and they'll get a certain percentage of it is carbon, certain percentage of it is hydrogen, certain percentage of it is oxygen, and from that, they can determine what the empirical structure was, the empirical formula for it was, and then they can figure out the molecular structure. Okay? So we're going to talk about the math today behind it. Ready? Okay.
I have to be.
Well,
I have a choice.
I mean, yeah, you have a point. I guess that makes all of us, huh?
Yeah.
Oh. Alright, so we need to have the relative weights of the elements that make up the compound. If they're not already provided, express these in terms of moles. Divide the number of moles by the minimum number of moles for each element. Create a ratio for the elements of the formula. And from that we can write the empirical. So, rather than just reading it, let's actually try it so you guys can see the process. Does that make sense? Okay. Alright, I'm going to start with this guy here. Alright, so I've got copper. You know I can hear you even though my back's turned. Alright, copper and sulfur. I'm going to assume with the percentage that I have 100 grams in my sample. Does that make sense? Because percent is per 100. So with carbon I have 66.4 grams. Instead of percent, I'm going to make it into grams. Good? Alright, sulfur I have 33.6 grams. Everyone follow what I did. So you take the percent and treat it as if it was grams. Alright, the next thing I'm going to put in what's called a conversion chart. I'm going to put grams here. 1 mole on top. Grams here. 1 mole on top. Does that make sense so far? I'm changing the grams to moles. Now the way I do that is I go to the empirical chart. Alright, looking at your empirical chart, what is the molar mass for copper? It's number 29. Yeah, 63 point. Alright, so you guys mind if we say it's 63.5, just for rounding sake? Okay. So I write that down here. 63.5. The reason why I'm doing 3 is because they gave me 3 here. So I'm just doing it to be consistent. Okay? Sulfur. What is the molar mass for sulfur? Sulfur is 16.
32.065.
Right, so we'll just round it to 32.1. Alright, so everyone understand the steps so far? Yes. No.
She's talking to you.
I'm talking to everyone, not just you two. Alright, so first thing we do, percent to grams, then I set my conversion chart, and then I put in my molar mass. Good so far? Alright, then what I'm gonna do is I'll do what's on top, multiply across the top, and divide by the bottom. You're welcome. Lots of things up today. Alright, so 66 times 1, of course, is just going to give me 66.4, and I'm going to divide by 63.5. So 66.4. Oh. 66.4 divide by 63.5. So it's going to give me 1.05, basically. And this is going to be moles. Grams cancel. I take 33.6, divide by 32.1, and I've got 1.05 moles. That's convenient. Notice something with this? It happens to be the same number, which is kind of nice. You would never guess that when you looked at this originally. So then what I do is I divide by the smallest number of moles. In this case, they're both the same. So I'm just going to divide by, I'm going to divide both of these by 1.05. Does that make sense? All right, I need a whole number. All right, so they both come out to be 1. That means I have 1 copper, I have 1 sulfur. Does that make sense to you all? So I have, my empirical formula is going to be Cu1S1. In fact, I don't even have to include the S, I can just say CUS. Really? Alright. Does this make sense so far? Alright, do you have this written down?
No, just, wait, so, how did you get this 62.5 again?
The 62,
No, 62.5.
I looked on the empirical chart and used my molar mass.
Whatever the molar mass is.
Correct, that's what that number is. This will always be the molar mass of whatever element you're working with each time.
Are we not gonna get that sheet, we're just gonna go,
I can print that sheet off and bring it over to you, not a problem.
but that's not what you're doing.
Yes, that was my intention.
No. So we don't need to write that down.
No, you do need to write this down because this is your answer to your first problem. That way you can put it on the sheet. Does that make sense? I had thought about just sending you guys the link and then having you do it from there, but I can print that whole paper off, it's not a problem. I'm going to do number 6 with you guys next. do is I'm gonna do just like I did before. I've got potassium, manganese, and oxygen. I change the percents and put a gram on it. Next thing I do is set my conversion charts. What goes on bottom? Yep, the molar mass, so it's grams over 1 mole. What's the molar mass of potassium? The Empirical charts are behind you too. I did put on the wall yesterday.
What is it?
Potassium K, which is 19.
39.09.
So 39.1 basically. Alright. Ladies, you see manganese, Mn. What number is it?
Which that is?
55.
Yes.
55, right?
55, yeah, 55.0. Alright, the last one, oxygen. Yep, 16.0. Alright, 16.0. Now we just do the math, so I take the top number, divide by the bottom one, basically. So, 39.8 divided by 39.1. So that one's gonna be 1.02. This is actually, 1.7, and the 1.7 rounds up to 2. The next one, 8 divided by 55 is 0.5. So I'm taking 3 numbers just like before. .5 divided by 16 is 2.03, and these are all moles. Follow so far? This one's nice because this one's different than what we did before. Now what we do is we take the smallest number and we divide everybody by it. So smallest one in this case, 0. 0.505. I'm gonna divide everybody by that. And I'm gonna round to a whole number. Cause I'm looking for ratios. It's not possible to have half of a oxygen atom, it's just not an option. Okay, so I'm going to take my bottom one, divide by 0.505. So it's 4.02, so it's basically 4. This of course will be 1, because I'm dividing by itself. And this one is going to be approximately 2. So it's 2.2 basically. Good?
Yeah.
Alright. So my formula is going to be 1, 2, 1. So potassium is 1, right? My manganese is going to be 2, and my oxygen is going to be 1. And that's my formula. Good so far?
No.
Is the process clear?
No.
Okay. Then I will print this off for you guys and let you guys practice this. And that's it. I will leave this up so you guys can start working on the next one while I go get the paper. So it doesn't slow your progress.
What time do me and Kate have to go over?
You're gonna go over at 11:05, so in 1 hour. For the, you guys go over at 11:20. I should be back by then. By the way, this will include the answers, so you guys can check your work.
Cause it's pizza.
No.
We're not walking with.
This is what the-
I'll bring my umbrella.
Yes, sir.
No, you just come to full school. Just need to be budget fifty.
Again. All this name calling.
Is that your guys coming tomorrow?
No. So we stay in.
Was she asking if you guys were gonna go over and pick it up, or? No, it was just what time you guys go over for delivering lunch.